All right, welcome to my YouTube channel. So this is a very important part of organic chemistry, and that is the IUPAC nomenclature. So IUPAC actually means International Union of Pure and Applied Chemistry, and they are the one responsible for the regularization of how you name any compound in chemistry, especially in organic chemistry. So nomenclature means naming of compound. All right. Now in our IUPAC nomenclature, all right, let me switch to dark mode. Okay, but background color black. Let me switch to dark mode. Okay, and make this white. Okay. All right, perfect. All right, now in IUPAC nomenclature, it's very important to know the rules that actually govern the naming of your organic compounds. And I'm going to be starting my this particular video by naming a really complex organic compound, like the one I sent yesterday on the group, like the one I sent to you guys yesterday. So we have this. Okay, I can't use this color because I'm now on black. So I'm using white. So I sent this question. So let's say this is your UTME question, and you are asked to name a compound like the CH3 to CH, open bracket, CH3 attached to CH2. Let me zoom out. Attached to CH2, then attached to C, then the C is attached to CH3 2, then that is also attached to CH double bond CH again, and then finally a CH3. Now before I draw out the structure of this particular organic compound, I want to say something. Your organic compound must start and end with CH3 always, except in cases that you have a functional group like COOH, or you have OH, or you have, I think, just these two. Those are like the exceptions. It can start with CH3 and end with this one. So are you getting me? But in a conventional, like in a much more, in a setting like this particular question, it should start with CH3 and end with CH3, because your beginning carbon, your first carbon, has to have 3 hydrogen attached to it. Now, how do you draw the structure of this very long, ridiculous guy here? Very simple. Start from the simplest. Start from the beginning. So you have C, hydrogen, hydrogen, hydrogen. That's the meaning of CH3. I don't know if you are following. Then you have CH as carbon with hydrogen somewhere. But in a bracket, there's CH3, meaning that CH3 is attached to this CH. So just put the CH3 down here. H3 like that. Then we have CH2, that's CH up, H down. So H. So far we have done this, this, and this. Then we have CH3 too. So you just pick that C like that. Then this CH3 means there are 2 methyl. So put 1 methyl up here, CH3. Put another methyl down here, CH3. Then your CH, that's CH. But immediately after this CH, you have a double bond, right? So double bond. Now count 1, 2, 3, 4. So the bond around this carbon is actually complete. So it will be like that. Then another C. Then 1, 2, 3. 1, 2, 3, 4. That's this CH, another CH, then CH3, CH3. H. So that is how to draw that structure. So now that you have drawn the structure, you have actually conquered the first step. So to name it is not going to be very hard again, since you already have the correct structure drawn out. Now the next thing is to check. There's a functional group here, and that functional group is this C dot bond C. And we remember that our C dot bond C is for what? It's for the alkene family, the ENE, the alkene family. So because of that, when you are naming, you want this functional group to take a small number. You don't want to have something like 10 in. No. You want to have something like maybe 1 or 2 or something very small, like 2 in, like 3 in, something very, very small. So how do you do that? It's actually not hard. So you now check, how can you count to get a smaller number? So you count like this: 1, 2, 3, 4, 5, 6. Meaning that this double bond is on carbon 6. If you count like this: 1, 2, 3, 4, 5. Oh, wait, 1, 2, 3, 4, 5. It means that this double bond is on carbon 5. But if you count like this: 1, 2, it means the double bond is attached to carbon 2. So don't count like 1, 2. Let me use another color so that will make sense. Don't count 1, 2, 3, 4, 5, 6, 7. No, because if you count that way, double bond is attached to carbon 5. But if you count this way instead: 1, 2, 3, 4, 5, 6, 7. Then your double bond is attached to carbon 2. Are you getting me now? To carbon 2 like this. So we are going to be counting in this direction. Are you getting that? So now we have secured that, okay, our double bond is on carbon 2. So meaning that our naming will end with 2 in. That will be the ending part of our naming. Then we have to count. How many carbon do we have? It's 7 altogether. 1, 2, 3, 4, 5, 6, 7. That's the longest chain. If you check another chain, we can't have more than 7. Like 1, 2, 3, 4, 5. Like 1, 2, 3, 4, 5. Like 1, 2, 3, 4, 5, 6, 7. Still 7. So let's just stick with this. So that's now what is 7? I'll show you before. I said 7 is F. 6 is X, 7 is F. So when you have carbon 7, that's F. So that means our formula is going to be, our name is going to be F 2 in. But we are not done. We now look at the substituents. What are the substituents we have? We have methyl. We have methyl. We also have another methyl. So let's check, where are those methyl found? No, first let's count. How many methyl do we have all together? We have 1, 2, 3. So that's trimethyl. If it is 4, that's tetramethyl. If it is 2, that's dimethyl. So trimethyl F2 in. Then we'll now check what is the position of those methyl. So we are counting like this. So that's 4, 4, 6. So we're going to write it as 4, 4, 6 trimethyl F2 in. So that's our final naming for that ridiculously long organic compound. So let me know if you understand it, and if you have any question, do well to comment it in the comment section below. Thank you for watching. See you in another video.